let's look at an example together that is not a parent function. So I'm going to make a note up here that this is not the parent function. Okay, so notice it does not look the same as this graph that we had in the notes part. This quadratic looks a little different, but it still has that same basic shape. It's just flipped upside down and moved. So for the vertex, that's always either your highest or your lowest point. So it's either a mountaintop or a valley. So our vertex is here, and that's at the point -2, 1. The axis of symmetry is the vertical line that goes right through the vertex. So whatever the x value is of your vertex, then x equals that number is your axis of symmetry. Is there a maximum or a minimum? Well, it depends on where your vertex is. Your vertex, if it's a mountaintop, that is called a maximum. So the highest part of the graph that it gets to is +1. This graph doesn't get any higher than that. Zeros. So where does this graph cross the x-axis? It crosses here at -3 and at -1. So that's the point -3, 0, and the point so that's the point -3. So that's the point -3, 0, and the point -1, 0. Roots, solutions, and x-intercepts are all the same thing. So those are also going to be -3, 0, and -1, 0. Y-intercept. This is one we haven't talked about yet. But the y-intercept is the same type of y-intercept that you talked about in Math 1. It's where the graph crosses the y-axis. So the graph crosses the y-axis at -3. So that's the point 0, -3. Finally, for the domain and range. The domain for a quadratic is always going to be -infinity to +infinity, or all real numbers. You can write this in interval notation, -infinity to infinity, and that just means that notice how this graph is cut off, but those arrows would continue. So that simply means, starting from your vertex, as you move to the left, this graph is continuing to move left on my screen a little bit, the further and further that you go. So that means that it's going to continue getting wider and wider and wider, which means the domain, or the spread, the horizontal spread of this graph, is going to continue getting wider and wider forever. So the domain, or the x values of this graph, are going to go from -infinity to +infinity. Now the range is a little different. The range is how high or how low does your graph get before it stops. So range is always talking about the y values. Well, notice how this graph, it only gets up to this high. It only goes up to +1. That's as high as it gets on the y-axis. Well, remember how I just showed you how the graph is going to continue going down forever and ever. That means that all of the negative numbers, all the way to -infinity, your graph is going to continue going that low. So the range is from -infinity to the maximum, which was 1. And I'm going to put a closed bracket on this one because that notes a stopping point. You can't really stop at -infinity, it just keeps going forever, but there's a hard stop at the y value 1. The graph doesn't get any higher than 1. Now if this graph were flipped, let's do a couple of practice. So I'm going to do numbers 1 and 2, and then you're going to do numbers 3 and 4. So for number 1, notice that this graph is flipped right side up. Let's start with the vertex. Okay, the vertex is always a mountain or a valley. In this case, it's the point -3, -4. The axis of symmetry, it's the line, the vertical line that goes through the vertex. And you have to look at the x value of the vertex. So that's x equals -3. Maximum or minimum? Depends on where our vertex is. Our vertex is in a valley, so that is a minimum. And where does it stop? Like, what is the minimum y value? If you look over, the graph gets as low as it goes at -4, so -4 is the minimum. For the zeros, roots, solutions, x-intercept, where does our graph cross the x-axis? That's what the zeros are. So that's at -5 and -1. So instead of writing the points, you can just write, you have zeros at x equals -5 and x equals -1. That's just a different way of writing what the zeros are. Okay, the y-intercept. Where does our graph cross the y-axis? It's kind of hard to tell because this graph is so small, but that's at +5, so that's at y equals 5. The domain, again, for all quadratics, because your graph is going to keep getting wider and wider regardless of whether it's faced up or down, it's always going to be a domain of all real numbers, or -infinity to +infinity. Now the range, again, you're talking about the y values. So how low does this graph get? Well, the lowest point on this graph is at -4. So when we're talking about range, we always want to list things from least to greatest. So if -4 is the lowest point, we're going to list that first. So that's our lowest, and it goes up forever. So this is the lowest part of the graph, and it continues to go up, right? Because this is going to keep going up forever, and this is going to keep going up forever. But this is the lowest point at -4. For example 2, this parabola is flipped upside down. So we have our vertex is a mountaintop, and that's at the point 2, 1. The axis of symmetry is the vertical line that goes through it, and it depends on the x value of the vertex. So that's x equals 2. Now, is our vertex a maximum or a minimum? It's a mountaintop, so that's a max. At what y value? So how high does this get? What is the maximum? It's at positive 1. The roots, zeros, solutions, x-intercepts, those are all the point where the graph crosses the x-axis. So that's at 1 and 3. The y-intercept, where does our graph cross the y-axis? That's at -3. The domain for all quadratics, it goes left forever and ever, so that's -infinity, and it goes right forever and ever, so that's positive infinity. The range is how high or how low does this graph get? So when you're looking at range, you always want to list the lowest number first. So if this graph goes down forever and ever, then the lowest number is -infinity, because you can't technically have a stopping point. It's just going to keep getting lower and lower and lower. So that's -infinity, and the biggest number, or the maximum, is positive 1. We already looked at that. Now, since it stops there, we can put a closed bracket around that.